Hey everyone, and welcome back for another Unreal C++ tutorial. In this video we'll be making what we have here in the background, which is the squash and stretch animation to the player when landing on the floor. This kind of comes from the previous video where I did a floating object in the world, and I realized that this actually worked really well using the timeline for something I really like adding is the squash and stretch kind of cartoony animation to really make things feel a little bit more organic in games, just to show that this would work perfectly well on something like a very standard cube as well. So this will be kind of building off of what we did previously, but this time we're going to make a timeline for our character class. Before we do that, just to mention again, if you haven't already done so, but you do enjoy the content, please do consider subscribing to the channel to be kept up to date with all of the content that I release. If you have already subscribed, please remember to hit that bell button. That really does help. So to get this working, we're going to jump into our character class. We can actually take a little bit of the code that we have in our previous timeline from the actor class. So if we already have the interactable base open, then the first thing we want is our component library. And we can put this straight up here, again, under the core minimal. I'm just going to go over to the code class as well, whilst I have this copied, and paste that in there as well. And of course, like we needed previously, we're going to have our curve float type again, because that will be fine for the squash and stretch animation. So we'll take that from the header of our interactable base and we'll paste that into our character class. So this time we're going to do this off of a function that we'll be overriding. So we want to do this when the player lands, basically. So if we go down to our previous public section where we have the current overrides, and we'll just add one here. So this is going to be virtual void override of landed. And this takes one argument, which is the constant value type of an f hit result, just called hit. So we won't need that, but as it's an override, we're going to need to include that. And then this, like I mentioned, is going to be very similar to our previous float timeline. So up in the public section, we can add our designer facing curve float. So this will be a U curve float called curve float. And again, we'll give this a U property of edit anywhere in a category of timeline. And then because we already have a private section here, I'm just going to put the variables in the private section. We don't need these to be exposed. The first thing we want will again be two f vectors, but this time we'll have a start scale and a target scale. And then we're going to have the f timeline, and we'll just call that the squash timeline. And then finally, again, we need our function that we'll be binding this to. So I'm going to call this one, this time just so it makes a little bit more sense, we'll be of type void again with a single float value override. And I'll call this one the squash progress. And again, we'll just add the U function specifier to this. And we'll make sure to create the definition for our new function. And like we've done in the past, we can make our variables here out of U properties if you wanted, again, for garbage collection and things, but I'm just going to leave that so that we can get into the code. So if we go on over to our code file, the first thing I want to do is in the constructor, I'm going to set the variable for our start and target scale. So I'm going to hard code these just because I know roughly what kind of works anyway. This might be something you want to expose into the inspector or get dynamically if you're scaling something which might have an odd transform or scale. But I know that I'm going to be doing the character, which is our cube, and I know that it's always going to be 1, 1, and 1 anyway because everything else is being scaled if needed. So that means I can just use this value because I know that for this project it won't be changing. So what I'm going to do is I'll come in and set the start scale to be an f vector of 1, 1, and 1, and the target scale to be an f vector of 1.3. 1.3, so the x and the y are being expanded, and then 0.8, so the z is being kind of contracted. So it looks as though it's getting shorter but wider. So that is our values set up. Now, we haven't done this on begin play because of course we don't want this to happen like it did last time on the begin play call. We only want this to happen when we land, so we don't need to begin play this time. And what we want to move to is our event tick. We can just immediately set this up on the event tick. So again, that we can pass in our delta. This time we've called this the squash timeline, so it's going to be squash timeline dot tick timeline delta time. Okay, so if we then do our squash progress function, I've just realized we've missed a step, but we'll go back and do that in a moment. For the squash progress, this is going to be very similar again. So we want an f vector, which will be our new scale. And this will equal again the fmath lerp between our start scale, the target scale, and the value. And with this, we're just going to update the mesh comp and set the world scale 3D to be our new scale we've just created. So the mesh comp is just something we've already set in the constructor when we created the class, which is the representation of the cube. And if you missed it as well, make sure that we add an equals here between a new scale and the fmath so that we actually assign this. And then the step that we've missed is we're going to come back and we need to implement our landed function. So again, just going to create a definition of this. We'll go back over and we can make sure that we call this function when the character lands. Okay, so first of all, because this is an override function, we'll call these super landed and just add in the hit result. Like we've done previously, we just want to check that we have a valid curve float to actually run through. So we'll say if curve float, and then inside of here we want to set our function again. So we want to bind this. So f on timeline float, and again we'll just call this one the timeline progress. We're going to bind this. So timeline progress dot bind u function. We want to bind it to this class, and the name we want to pass in of the function to bind it to is the squash progress. So we can close that off, and then the final two things we want to get the squash timeline dot add interp float, the curve float, and our timeline progress. And this time we just want to make sure that we set the squash timeline dot set looping to be false, as we only want this to play once. And then finally we want to call the squash timeline dot play from start. Okay, so with all of that done, we can once again compile. We can go back and we'll need to add a quick float curve in our editor. So if we do that first, I'm going to copy the curve float that we already have. If you don't already have this, then we can right click, go misc and curve. Make sure that you select the curve float. But because I've already got some of the points that I need here, I'm just going to copy this and I'll call this one curve squash. So the only real changes I need to make in here, I still want the 3 points. So again, the start scale, the squashed scale, and then returning back to our standard. So we've got the start, the end, and then the start again, so that we set the character back to where to the size it was. All I want to do is we can leave the first one as 0, 0, set the second one to be a time of around, we'll say 0.1, a value of 1, and then the final one to be a time of about 0.2. You can see a moment ago as well, it came up saying the hot compile reload was successful. So just to confirm, the build has all gone through successfully in our C++ file. With the hot reload successful, we should be able to go straight into the character, and we can see we've got our new curve float available here. So I'm going to add in the curve squash, and if we press play, this should just work now. So when we land, we should be getting our squash effect happening. So we'll just go back to our function here and see what's happening. Okay, and I can see the error. So I've called this the correct thing, which is squash, spelled correctly. Just here, I've actually called this squash progress. So I'm just going to come back in to the header file, the extra S that we need just here. And of course, we just need to make sure we update that in our code file. And I paused there because that started looking a little bit weird. It's one of those things where the words just lost meaning. But if we compile this, this should now work. Obviously, we didn't get any compile errors because this is just referencing a string value, but that just wasn't being found when we were playing. So that has now compiled again. And there we go. We can see we get a nice little bounce when we hit the floor, just to make the character look a little bit more interesting. We can also remove our debug string, just so that doesn't happen every single time that we land. And that now means, of course, that we have full control over how exaggerated this is, how much we want this to stretch, so we can increase the squash by changing the curve float that we have here, or we can make it happen at a different time by moving it down. And things like this for very different results, but very easily tweakable, and it just makes things look very a little bit more interesting when the player's moving around. So I'll leave that there. They were just a couple of different ways that we've seen in this video and the last video, how we can use floats and timelines in C++ just to add a little bit more juice and interest to the game. As always though, if you enjoy these videos or find them useful, please do leave a like and share the video around. That always helps. And of course, if you haven't already, then consider subscribing to the channel to be kept up to date with any of the content coming from any of the playlists on the channel. And of course, if you already have, then just make sure that you hit the small bell notification icon. And as ever, thanks for watching, and I will see you all next time.